Hello guys, I'll be talking about a topic from numerical analysis which is called bisection methods. And in this tutorial I will be solving two examples. So this is our first example. It says use the bisection method to make the smaller root of the equation. Here's our equation. Check convergence by our error equal to 10 raised to the power minus 3 using absolute successive error. So the first thing you have to do is to write out our function. So our function in this question is x cubed plus 3x squared minus 3 equal to 0, which is that's our function. Then the next step is to take the derivative of our function. So the derivative will be x squared will be 3, and x cubed will be 3x squared plus 6x, which is equal to 0. Because this 3 will come down, like if you want to take the derivative, it will be x raised to power n minus 1. So if we have like this x cubed that we have here, we have x cubed, so this 3 must come down. Then you deduct 1 from the power. So we have I'll still make video on derivative, so you have knowledge on how to take the derivative of any function. So let's proceed. So after taking the derivative, the next step is to construct a table. And what are we doing with the table? What we are trying to do is to find the smaller root. We need to find the smaller root. But you will understand what I mean by that. Let's construct the table. There's the table. This is the table, and we have x, we have sine of our function, so some people start from minus 5, minus 4. They start taking the root from minus 5, minus 4. But me, in this tutorial, in order to make sure I don't take much of the time, because I don't have much time, so I'll be starting from minus 3. So I start from minus 3, minus 2, minus 1, 0, 1, 2, and 3. Yeah. So what are we doing with this? We will be plugging this into our function, not into our derivative. We'll be putting all these values into this our function that is already given here. So we'll be checking if it is negative or positive. So here, if we put minus 3 into this function, let me bring out my calculator. We have, it will be minus 3 cubed plus 3 minus 3 squared minus 3. So our answer is a negative number, so we just put our sign here, which is negative. Then here I will adjust this. I will put minus 2 because after finding minus 3 is minus 2. So we put minus 2 here. Minus 2. Minus 2. Yes. So if we put minus 2 into our function here, this one will be minus 2 cubed, which is minus 8, which is minus 8 plus, we put minus 2 squared is 4 times 3 is 12, then minus 3. You see that our answer is 1, which is positive. So we put positive sign here. Then same thing, we put minus 1 here. If you put minus 1 here, we have negative here, which is minus 1 plus, no, minus 1. If you put minus 1 here, minus 1 squared is 1. 1 times 3 is 3. That's plus 3 minus 3. It is negative. Then if you put 0 here, 0 is to power anything 0. 0 plus 0, 0. 0 minus 3. So this one will give us a negative sign. And you do the same thing. You put 1, you put 2, you put 3. So if you put 1 here, we have positive. If you put 2, we have positive. Also 3, which will be positive. Just try it. Just try to check with your calculator. So that's it. So we have here. You just have to check where the sign changes. So it changes here. It changes here. It also changes here. It also changes here. As you can see, from negative to positive, then here from negative to negative, so it's not changing here. As you can see, from here to here is changing, from here to here is not changing, from here to here is not changing. So we write our roots. Our roots are in minus 3, minus 2. That's first one, which is this one. From here to here, from minus 2 to minus 3. Then the next one is from minus 2. Right. Minus 2, minus 1, and also 0 and 1. So this is all what we have. Since we are considering the smallest root, here we have this interval. We have 3 intervals here. We have this, and also this. So, but we need the smaller root, as you can see in the question. Smaller root. So which one is the smallest here? This is the smallest, because we have minus 3 and minus 2. They are smaller than this and also this. So this is the smallest one. So we choose this interval as our starting point. So let's proceed. So our interval now will now be minus 3 and minus 2. So we call that A0 will be minus 3 and B0 will be minus 2. So we also need C naught. So to find C naught, the formula for C naught is A naught plus B naught divided by 2. So here, if we put our values here, A naught is minus 3. We have minus 3 plus minus 2 plus minus 2 divided by 2. So if we did this with our calculator, we have minus 3 plus minus 2 divided by 2. But our answer is minus 2.5. So we can write our C naught here, minus 2.5. So we call this our first iteration when n equal to 0. So let's move on. The next thing we have to do is to find when our n equal to 1. So for us to be able to do that, we have to plug in all these values. I mean A naught, B naught, and C naught. You have to plug in minus 3, minus 2, and minus 2.5 into our function, which is this one, still our function. So have this in mind that we are not using f prime here, like derivative of f, we are not using it here at all. So we are only using our function. So I only took this derivative so that you know that you just have to put that one too into consideration. But here we are dealing with our function. So you have to put these things into our function. So if you put, we try to do that here. We put minus 3 into our function, and we got a negative sign. So it will be, so you just have to write f minus 3. Since it's negative, so it is less than 0. Then f of minus 2, if you plug in minus 2 into our function, we find it here to be positive, is greater than 0. Then we have to plug in our minus 2.5. So, and if you do that, you'll find that your answer will be positive as well. So f of minus 2.5 is also greater than 0. So we now have to choose the values to use now. We have to choose the point to use now, because our A0, B0, and C0, sorry, A naught, B naught, and C naught, we already know that one. So we now need A1, B2, B1, and C1. So how do we find that? When n equal to 1. So this when n equal to 0 here. So when it's equal to 1. So what you have to do here is, since we are looking for the smallest root. So what you have to do here is, you have to look into these things you just find, this function you just find here. You have to look into it. We have negative, we have positive, we have positive. So you can only choose the point where the signs are changing. Yes, the point where the signs are changing. So here it's negative, here it's positive. But this one is positive and positive. So we cannot choose minus 2 and minus 2.5. We can only choose minus 3 and minus 2, or minus 3 and minus 2.5. Because this is negative, and the next sign you should choose must be positive. You can't choose positive and positive here. So we can choose either minus 3 or minus 2 or minus 3, and minus 2.5. So those are the two. So those are the two values you can choose here. But since we are looking for the smallest root, we cannot choose. We cannot choose minus 3 and minus 2. So what you have to do is to choose your new value, which is minus 2.5 that we just find from which is our C naught. So we have to choose minus 3 and minus 2.5 because minus 2.5 is new value here. So our A1 will be equal to minus 3. A will always have the smallest value. So here we have minus 3 and minus 2.5. So we have to use minus 3 for A, and our B will be equal to minus 2.5. So we use the same formula to find C1. This formula here, this to find C1. We write C1 will be equal to what? A1 plus B1, sorry, B is B1, divided by 2. So if we calculate this, our result will be, so just have to put this minus 3 plus minus 2.5 divided by 2. So our C1 will be equal to minus 2.75. So that's our C1. So we have A1, B1, and C1 is minus 2.75. Now, when n equal to 2, so what you just have to do the same thing here by putting all these our new values into the function, here, our function here. Yeah, sorry. I have to put it into our function here. So by putting that, we have I'm running out of time. I just have to hurry up. So if we put f of minus 3, we already know that it is negative in our previous iteration. It is negative. Then if you put f of minus 2.5, it will be positive. And if you put minus 2.75 into the function as well, it will be less than 0. It will be negative. So we have this, and this. We have negative, positive, and positive here. You can either choose between this and this, or this and this, but you cannot choose this and this because both are negative. I told you in the other iteration that you can't choose the same signs. You have to choose different signs. Yeah, so which one are we going to choose here? So n equal to 2. So which one are we choosing here? You have to choose between this and this, or this and this. Yes. So you have. So we now have. You have to choose your list value that you got. So our list value here is this and this. So we have to choose this and this and ignore this one here, because this one we've been using it for some time, and when we got to this place we can choose between this and this, or this and this, but you just have to. So what let me even write it down so that you can understand it. We can either choose between f of minus 3 because it's less than 0. You can choose this and this. You can choose this, either this, or you can choose f of minus 2.5 and f minus 2.75. Yeah, so you can choose this or this. You can choose this or this as your new values. So but here we have to choose the least one, the least value. The least value that we got was this, so we have to use this. We have to ignore minus 2 because we've used it in two iterations. So now we use this minus 2.5 and minus 2.75 as our new values. So A2 will be minus 2.75 and A3 and B2 will be minus 2.5. So to find C2, you use the same formula that I used. It will be A2 plus B2 divided by 2. So if you put these two values into our equation, we find out that our answer will be minus 2.625. Yeah, so you just have to continue like that. But if you want to know where the iteration will stop, then you have to use a formula, and this is the formula: n equal to integer ln b minus a minus ln a divided by ln 2. So this is the formula we use to find to know where our iteration will stop, because we can't just continue like this, continue iterating. It will take a lot of time. The only thing they can ask you in the exam is just find the bisection, find the smallest root by doing two iterations and finding where it will stop. So if you want to know where it will stop, then you use this formula here. Now let's use this formula to know where our iteration will stop. So n will be equal to integer ln. So we choose our the first root we used. So the first one we used was minus 3, minus 2, and minus 3 and minus 2. So we put minus 3 and minus 2 into this equation here. So we put b was minus 2. So we put minus 2 minus, then a naught was minus 3 minus ln. So in the example we see this, like this one is given to us. Our error is 10 raised to power minus 3. So we put that here, ln 10 raised to power minus 3 divided by ln 2. So if we calculate this with our calculator, we find out that the number of iteration will be int 9.965, which is approximately 10. So this iteration will last for 10. We have to go through 10 steps. So, and you know that we can't be doing all these iterations, like first iteration, second one, up to 10. So we just have to stop here and find where the iteration will stop. But you can continue from here. Just try to test it. Follow the same step the same method that I used. Just use the same method, and you find out that it's still the same thing you will get. When you get to 10, when you get to the last iteration, which is 10, then you see that it will be less than this. It will be less than our error here. So that's all for this video. In the next video, I'll be solving one more example on bisection. Thank you guys for watching.